Okay, so that is for the introduction. I think I will start with the Python web app. I think that is the app which needs the least changes compared to a normal workflow. So, okay, I will just open the spec editor, and I have created a completely blank spec. So for the ones who are not that familiar with the spec editor, so this is the part where you put your pipe elements, what you want to use in the actual project. So at the bottom part, there is the catalog with all the different stuff you can possibly draw in Plant 3D, and on the top you have the spec, which is the actual spec you are using in the project. So, okay. So it is a completely blank. Nothing is here. I named it webinar for the simplest sake. So, okay. I'm also using inch pipe or imperial pipes as well sometimes, but how to say, I am more comfortable with metric dimensions, so I will start with that one. But my apps are completely working fine with imperial dimensions as well. So okay, I just now I just add some bends and some stuff. I just fill up this spec with totally normal stuff. Just a moment. I will give some, okay. I just add some flanges. Gaskets, bolt, I add the pipe and some fittings, a bend, T, maybe reducer as well. So now I have a spec which is mostly working. Bend, 90-degree bend. Save. Okay, I just go to the Plant 3D and I will open just a drawing. And in the specs, I will copy this spec there. Okay. So this is the webinar spec now. So you can see here that I have some bends here, some flange, a pipe, a reducer, and the TP is there. So now you know no valves yet, but I can draw the pipes. So I will go back to the spec editor and open the inbuilt valve catalog, bin valve catalog. So the problem at least I have with this kind of catalog, that these valves are looking a little bit too simple for me. I mean, it works. So if I add, for example, I don't know, shutter butterfly valve. Oh, butterfly valve. I can add this to the spec. I go here and refresh the spec. So the butterfly valve is here, and it is working, but an actual butterfly valve does not look like this. Okay, it's similar. Maybe even some main dimensions are okay, but I have some problem with it, and many of my clients told me to have the same issues. So even if I want to edit one of these butterfly valves, actually the dimensions are very limited. I can edit the lengths and the diameters, but that's all. So what my app is doing, that it gives you the possibility to make additional valves, which are more realistic and more closer to the real life. So if I hit create new component and go to valves, you will see all these colored icons. These are additional stuff which is not there in Trans 3D by default. So the default ones are these gray ones. Sometime somebody will explain to me what is this valve and why there are so many of them here, but okay. So my ones are these blue ones, and they are actually, at least according to my humble opinion, much more realistic than the ones Trans 3D provides. And they are fully parametric. So if I hit create one of them, just, I don't know, DN80, 3-inch. This is the one I want to create. So you can see there are so many parameters. At first it's even maybe too complicated. So this is the valve body parameters. It is common for every kind of actuator. So you can adjust basically the whole geometry here. And based on which A parameter is not zero, you can define different kind of actuators here. So for example, if I change A2 to some value, because by default it is 0, it will generate a pneumatic actuator here. Or with A4, you can generate a geared, I don't know, wheel with it. With A3, you can generate a simple handle with that. So basically, my app can give you the possibility to make much more realistic valves. And it is not just visually pleasing stuff, it's actually useful as well, because if you don't know what is the actual height of an actuator or the diameter of the wheel, because you cannot visualize it with the inbuilt script, it is really troublesome. So,
Thomas,
yes.
In the previous screen where you had all the variables to change the.
Yes.
Is there a way that you could enter all those variables in an Excel file, import the Excel file, so it would be faster to create a whole bunch of, or modify a whole bunch of valves at once?
Sure. I mean, okay.
Because you can see that if you do this for like every pipe size, if maybe you have 10 different pipe sizes,
yes,
and you have multiple specs.
Okay, I will maybe demonstrate one for you. Just a moment. I go to my own catalog. These are the catalogs which are created and included in the app. So if you install it, this catalog will be there. So this is a metric catalog. I have another catalog as well. It is also included with that. That is imperial, inch based. So these are all the sizes. If you see, the parameters are changing when I am clicking on the different sizes. So all are filled up. So just to demonstrate how to make a new one, I will hit create. Short description will be webinar 12. Okay. I will keep it as metric because I will possibly make an error if I am going to inches. Okay. Let's make, I don't know, relatively simple one, this one. Okay, I just hit create. So at first, I will fill up the general stuff. It is metrics, so and flanged. So I will put FL, yes, both. Facings will be C in this case, pressure plus 10. Long description is like that. All ports have the same size, so it is 60.3 millimeter because it is 50 and 50. Long description size I will not fill up now. Okay, so I will keep the dimensions for this valve as it is right now. I'm lucky because this is for DN50. It is filled up by default. Flange diameter FL is 120. I guess it's okay. FT is 18. Yes, okay. So I hit save to catalog. Okay. So now we have one single valve. Okay, one size. We have this 50. Okay. And now I will just make duplicate size, this button. So I will just duplicate, and okay, I will enter 65, that is, I don't know, 76 actually. All ports have the same, okay. 80, 88.9, 100. This is 1.3, 150, 200. So I'm just filling up the nominal sizes now. We will get to your point for just a sec. So now I made a bunch of sizes, right? From DN50 to DN300. So it can cover actually, in my case, my usual projects have these kind of sizes usually. So it is already covering that one. So now, because I duplicated the sizes, all the dimensions here on the side, the FP, FD, FD, FL, whatever, are the same for each size. So actually for DN300, it will be a very small valve. So now, to answer your questions, you have this export to Excel button here. So if I export this to the Excel desktop, I will just, I will just name it 1.xls. And then it is exporting. Actually, I opened my catalog because it has fewer items than the inbuilt ones, because now it is not actually exporting the showed item here. It is actually exporting the whole catalog.
Oh, catalog, okay.
So now I go to the Excel. I hope it will be working fine. Okay. Sorry, my Excel is in Hungarian, but I think you will get the idea. So at the bottom part, you can see that there are the different parts which are created. So each tab shows one valve family or whatever.
Yeah.
And you see, this is the webinar valve that I have created right now. So all sizes are here. This is actually the name of the script, the Python script, which should be used for the valve. And these are the parameters which are, how to say, transported to the script to generate the geometry. So basically, you can change the dimensions of every size right here in the Excel. You have to do some magic because it is a, how to say, it is a protected file, or somehow I never find where it is. Just a moment. Okay. You have to hit editing anyhow, even though it is very dangerous. Then you have to allow editing here as well. And then, okay, I will just change, let's say, this diameter, the flange diameter. So 180, 200, 210, 300, 350, 400, 450.
Yeah, that way you can go quite quickly through a catalog and just transfer the data.
Yeah.
Instead of going through the interface, which is slow and takes a
yeah, and sometimes it, how to say, go to fatal error and it just exits. and you haven't saved in the last 10 minutes. So yeah, I just saved this Excel sheet, close it. I go back to the spec editor, import, go to the desktop, one.xls, and now
import.
It is verifying the import data. So actually it is now searching what is changed and what remains as it was before. It can take long time, very long time actually, if it is a very big catalog. So I mean, if you go to the piping catalog, it can be very big. So here you have to click on the plus sign, again, valve, plus sign, and go here. So there is a yellow marking what is changed. So we have not touched the other valves, but this one is changed. And you see the first line, I haven't changed the flange diameter, but for the rest I changed. So except the first line, the others are marked with this yellow color. And also the cells which are changed marked with yellow color. And it is important that you have to hit accept all changes in this window. So if I hit accept all changes, everything goes back to white. And if I hit OK and I check the diameter, it should, just a moment. It is already changed. You see 180. 200, 222, at the 300, it is 450. So this way you can quite efficiently create a new valve with all the sizes.
That's great, yeah.
So this is how I usually, actually, this is how I created all the valves here. Obviously, this is, I don't know how many sizes. Obviously, I did not fill up all these values here. It is really painful to make it here. All were done in Excel. Yes, sure. Okay. So as I showed to you, back to the topic. So I did not really like how the individual valves look like, and some of my clients and I can say now friends told me that it would be nice to have some much more better looking valve. So that's why I've created this app, and with the inbuilt catalog, I can already show you some items which are there. So although it is a live catalog, and expansion join is also here. Gate valve, I don't know, and I will add a butterfly valve if I find one. Okay, so save. So I go back here, I refresh the spec. So now you can see also here on the screen that the blue icons are showing which are made with not the default scripts, but the ones I provide. So for example, this is a expansion joint which can be useful, I guess. I don't know why it is not such an expansion joint is there by default. So this is a pneumatic butterfly valve, for example. And this is a pneumatic gate valve, just an example. Also, these items are, maybe it is a little thing, but it was also annoying to me that if I import something from inventor or step file, it was really painful to make sure that everything is working regarding the color coding as well. So for example, if I draw a 100 diameter pipe or a 150 diameter pipe, Plan 3D is color code. Oh, it's also yellow.
Yeah, you'd have to change this, the default coding in Plant. Is it in Project Manager?
Okay, yeah. So it is different colors, and if you have a step file, which is then, even if you convert it to a valve or a Plan 3D object, it will not work with this color coding, but these kind of scripts are working. So if I enter this valve, it is blue as well. So it is completely working as the inbuilt stuff. So okay, it is not actually really beneficial at the end product, which is the 2D drawings, but I think it's also nice to look at in the 3D model. Thinking what else? What is also important thing is that I don't know if everybody else knows this, but here in the spec editor, on the spec editor tab, so inside the spec editor, it is the spec editor tab. At the top part, which is showing the actual spec, what you are using, if you double click on any item, you have this menu, which is showing basically what is there in that line, what that line represents. Mm-hmm. All these sizes for the Python expansion joint, for example. So one thing is important here, I think, at least it was really, how to say, important in my case, that there is this component designation column, this one. And if you enter parametric, I mean, by default, it is empty, nothing here by default. Every item is empty. Most of the items, let's say, are empty here. So if you enter here parametric or custom, it will make this item, at least that size, editable in Plan 3D. I mean, in the 3D space. So now, if you see for the expansion joint, it is already there. So parametric is also already entered to every line. So therefore, if I click on this expansion joint and go to the properties, you will have this part geometry area. If you don't enter parametric or custom at that field in the spec editor, this window will not appear in here. but if it's there, it appears. So for example, I have an expansion joint. Expansion joint obviously can expand. So if I want to represent that it is actually not 200, but I don't know, 250, it will just expand. So you can edit it right here. Like you can expand it like a pipe. Okay, not totally because dragging this endpoint is not working, but you can manually enter 300 here and it is also working. Even moves the connected flange with it.
So you can do that with the valves too?
Oh, it is a long story. Good question.
Well, you shouldn't have to really, because the
yeah, you shouldn't have to, because why would you change the end-to-end connection distance of a valve? I mean, it is a standard thing, but actually, I had one thing which was really annoying for me. You know, what if I want to rotate the pneumatic actuator 90 degrees here? Because it can happen that I want to rotate this. The actuator can be installed this way or, I don't know, 90 degrees rotated, if you understand what I mean. But maybe for the whole project, every valve is like this. But because of the installation, I want to rotate one valve like that. So, yes, I want to maybe. There is a scenario when I want to edit the valves in the 3D space as well. And honestly, for 2.5 years, I couldn't do it. And I did not understand why. Even if I entered parametric, I entered custom, I entered many stuff there, but it was simply not working. And I dug out some forums and Autodesk posts and stuff like that. And I found out that I had to name the Python script file, the actual file, in a certain way to make this available. But it is only valid for valves. So for this kind of expansion joints, I don't have any restrictions regarding the naming, but for valves, don't ask me why, but there is this restriction. And I have to put CPV. I will remember this until I die. So I have to put these 3 letters in front of the file name and the Python script name, CPV. And if I do that, editing valves is possible. I don't know if it's the latest update of my app on this computer, but it's okay. It should be editable. So
that's fairly common, that you will show an actuator just to be able to indicate that it's a control valve or a motor operated valve. And then later, when you get the actual actuator, you've got to change the size of it. Because at the beginning, you probably are not going to know the actual size and model of the actuator.
Yeah.
But it's important to see visually in the model that it is an automatically, a controlled valve, a non-manual valve. Yeah, so it'd be nice if you can just go in there and modify that, click, 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 and it's done.
Yeah, so as you can see here, there is still one step I don't understand. So for example, the expansion joints, you can see in the properties window that I have this picture, and below the picture, there are the parameters, what I can change. For the valves, funny things, I only managed to have the parameters, but I don't have the picture what each parameter is doing, but you can check in the spec editor. So for example, I know that delta is, I think, the one which is, you see, rotating the actuator. So, okay, so it was a long journey. So what you see here, rotating this actuator, actually took me 2 years because of this CPV prefix necessary for the Python scripts. But oh, okay. Finally it was managed. Okay, so time is passing by. So I would like to show you at least briefly my other apps as well. If I don't know, Paul or any others, do you have any question regarding this web?
Well, I guess what would be interesting to see if you could do it, is there a way to measure the file size of these valves that and compare them to the file size that you would have to use if you got a manufacturer's step file and put them in the model? Because then you could see the difference, for people who are thinking about buying the software, they could say,
Okay. Okay, so this is I don't know, there are some stuff here, but okay, I delete this one. I just hit purge all items, close, save. I hope purge is working properly. Okay, so you can see here, there are some valves here, and it is less than 1 megabyte now. Okay, and I don't know if I enter some more, let's say 200, 300, 600, a smaller one, 40. So I enter some valves here, also the gate valve. Ah, I don't have the M40 gate valve. I guess it's too small. Okay. Okay, I just hit save again. So it's 1.25 megabytes, and I have quite some valves now, all different sizes. I guess, honestly speaking, I think one step file this size can increase your.
Yeah, well, step files are, it depends, but you're looking at least, I don't know.
Yeah, so it's
half a meg.
Yeah, so it is 1.25 megabyte, and I already having some valves here. So it's definitely, how to say, it is just basically AutoCAD solids, what you are seeing here. So nothing special. It is just cylinders and boxes with different shapes, cones and stuff. So I'm pretty sure that smaller size with this visual effect cannot be achieved because it is done by AutoCAD itself.
Okay. So are you going to move on to a different product now?
Yeah, I would like to show you at least briefly the other 3 apps, if you don't mind. Okay. So the other thing which I can show you, maybe it's not that.
Not in that detail, but yeah.
Yeah. Okay. So this is what I mentioned at the end of my introduction, that I have where I work. We regularly use this kind of stuff, these lined bands, which actually have inbuilt flanges, which are also loose flange. So, for example, if you want to have this kind of stuff in Plant 3D, at least I couldn't do that with loose flange. I could not generate a geometry which resembles this thing. So that's why I created these kind of TPCs, I don't know, bands with some extensions and stuff like that. So it is also working in the same way as the valves. So for example, I just able to give this stuff to the spec. and they will be there. So if I go here and refresh the spec, for example, this is a high radius. Okay, I did not give this special French here, but okay, you can get the idea that this is a this is actually, we are using it for pneumatic conveying. You know, we are conveying sand-like material, and when there is a direction change, you have huge abrasion. So these kind of pipes are ceramic or basalt line stuff. So that's why it is having this bigger diameter, because it is having some 25 millimeter or 1 inch thick ceramic lining.
So it's lined pipe. When you said lined pipe, I was thinking jacketed pipe.
Okay.
Is there?
But honestly, representing the stuff, nothing. I think it is there is no difference. Maybe the jacketed pipe needs some additional connection. I don't know if you are cooling or heating something.
Yeah, well, that's something that I'd like to talk to you about later, because we're using a lot of that, and it's causing a lot of trouble and more time to be spent, and I'll explain it all later. But
okay,
that's very interesting though, because there's no way to do this lined pipe in AutoCAD now.
Yeah, sure. Okay, so this is okay. As I told you, it's kind of special. I made it honestly for my own personal work, but still I uploaded it for the App Store, and actually quite some people downloaded it and told me that it's quite useful for them. So yeah, sure. But yeah, it can be interesting to make it how to say, representation wise, other than the two connections. I think it is exactly the same thing as a jacketed pipe as well. Okay, so this was the lined pipe app. Okay, the other thing is that, which is a little bit more complicated, because we have a pipe support spec. So every project has many pipe spec. You see here, you can as many pipe spec as you want. But pipe support spec, as far as I understand, there is one dedicated pipe support spec. So this is the pipe support spec of this project. And if you want to add something additional here, some different kind of pipe support here, it should be also done in the spec editor. So I will try to open the spec of the pipe supports now of that project. So these are the supports what's currently there. I have some custom made stuff here, so I will delete that. So what is up here is the ones which are inbuilt in Blend 3D. So these are also kind of limited. So if I go here, I open the catalog, just a moment. Support catalog metric. So these are the inbuilt stuff what Blend 3D provides, these black and white pictures. So if you download my app, my Python pipe support app, you will have some additional options. So if I hit create new component now, you see these blue icons again. These are the ones which I have created. The gray ones are the default ones. So if I go here, you will see, okay. you see that I have some additional stuff going on here. So these are the ones which can be created with my app. So there are some bunch of pipe supports. So all are these are working in the same way as the one which are there in Plan 3D by default, but I guess they are also more realistic. They are actually there in the real life. For example, I don't know, I create this one, DN80 3-inch, create this one. So this is a profile with some base plate, some routing, and LP is here, LP is there. And you can also change the profile with an additional parameter. So there is this TY, this type profile I created. This is this here. If it is 1, both profiles are L. If it is 2, both profiles are H. If it's 3, both profiles are U profiles or C profiles. I don't know. And also you can change the parameters here. So I'll just create this one and show to you. It is then not here, here. Python pipe support 48, if I would remember. I just put some dash in front of it to find it easier. Okay. It's here. I give it here. So I added it to the project pipe support spec, and now I just save it. Okay, one thing, if anybody has better solution, I am happy to hear, but I can only refresh the pipe support spec if I close the AutoCAD. I have to restart it. I could not find any other solution to refresh the project pipe support spec in the Plan 3D. So
yeah, I've started not using the palette and just opening the spec viewer instead because
okay. Is it refreshing?
Because there's no way there's no way that I would shut down a big huge model and then have to wait. But you're not going
to. But okay, it's how to say.
You won't be making those changes very often.
Yeah, so. Usually, if you are into the project, it's already finalized. I mean the pipe support spec, I guess. Okay, just a moment. Okay, so if I go to the pipe support spec, I have this just created support, and I can use it. Okay, not the DN80. Wait. This one, the DN80. So it is the support here, and it is also how to say here the drag points are also working. So if I put it here, it is also working like this. If I want to make it wider, it is also working the same way as it is working with the inbuilt stuff.
Yeah, that's nice.
So this is how it is working. Also the parameters, if I go to the properties window, it is also working the same way. Yeah, routing and base plate can also be turned off by making them 0. So if you want to, I don't know, directly weld it to somewhere, it is also possible to indicate it like this. Okay, and the final app what I would like to show is the cable tray app, which I mentioned at the very beginning of the introduction. It is I will open the catalog. It would need a longer, probably dedicated webinar for just this one, but I will show you the basics. So with this kind of items, you can see it is, you can create straight cable trays, tees, reducers, whatever you want. And it is working the same way as pipe elements. The only limiting factor is that pipe, as a real pipe, cannot be used in a cable tray. So the straight cable tray is not working like a pipe, it is working like a sleeve. I will show you in just a moment. So I will open the webinar catalog just for the simple sake, and I will add this straight cable tray there. Let's say an upwards pointing cable tray, and I don't know, a band. And I just save it. I go back here, refresh the spec, and go to webinar spec. So you can, here you can see these items, this blue looking cable tray stuff. So this is a cable tray, which just a general cable tray, and there are some bands here. This snapping, as would like with the simple pipe elements. So yeah, that was my first big issue with Plan 3D, that I could not draw cable trays, and that put me on a trajectory that I am here and presenting my apps, because I really wanted to solve this issue.
That's what started all of this, right?
Yeah, so yeah, because it was really painful to switch back and forth between an electrical program and Plan 3D. So if there was a collision, it was really painful to work with the constantly X-revved stuff instead of just editing on the fly. So yeah, this is this is how it is working. It is like pipe elements. Even ISO is working on them. I don't know. I'm not sure if ISO is a real thing for cable trays, but many clients asking it from me. Okay, and actually, the most limiting factor of this app, this cable tray app, is the straight stuff. That is the difficult thing, because if you click on the plus sign here in Plan 3D, it will always draw pipe. Whatever I do, it is pipe always. I could not overcome that, but so dragging this is just moving the stuff. So if, for example, if you want to increase the length of this straight section, you have to go to the properties and just L1 is, I don't know, 2,500, and it will increase it.
Okay.
So that is the big limitation right now in this app, but honestly speaking, I think it's still way better than using another software for drawing the cable trays.
Okay. Well, thank you, Tamas, for demonstrating your software.
Oh, no problem. Thank you for the opportunity and having me here.
I will.